So this is an interesting place for me to be now, because I think the word complexity would not have had much resonance in maybe a few years ago, but now complexity is sort of becoming a thing that people talk about. And I think, like Stephen Hawking's, what happens to the brief history of time, it's a thing that now everybody thinks they should talk about, but everybody had that book on their desk, but nobody read it. But anyway, so Stephen Hawking said, I think the 21st century is going to be the age of complexity. What I want to say is, I'm going to start out with an article that was written by Danny Roderick and the two co-authors in the Boston Review, and in which he said, they said, you know, economists should be enablers of democratic priorities, not oracles challenging a supply and demand deity. But a number of us thought that they hadn't gone far enough. So we published a response to that. And I'm sorry it's a bit long, but I won't read you the whole thing. But I think that sums up pretty much our view of it. And you will see down at the bottom there are a number of well-known associates, people who Angus has been involved with, like Eric Beinhocker from INET in Oxford, and Brian Arthur, who was one of the early pioneers in complexity. But anyway, the point is, what it says here, look at where our backgrounds are from. Economics, political science, psychology, anthropology, physics, computer science, evolutionary theory, and complex systems theory. To us, the phenomenon called the economy is a highly complex, multi-level system that encompasses human biology, human behavior, group behavior, institutions, technologies, and culture, all mutually entangled in networks of non-linear dynamic feedback. And all of those things are terribly important. Each of these levels in the systems is subject to learning, adaptation, evolutionary, and co-evolutionary processes. But when you go to your first degree in economics, is that the sort of picture that you're given? Not at all. You examine the individual and how he behaves, and after a while you think of him as maybe being situated in some sort of society. And what we claim there is that the transdisciplinary perspective, which some people like to call complexity economics, is different in a number of significant ways from the traditional perspective on economics. Now, we've had a long history, as you all know, of being wedded to physics. And for probably over a century, we had models which were essentially based on physics. And Jevons, Keynes, even Pareto, he said, you know, when I look at the equations that we solve, these are old friends. They're the equations of rational mechanics. So we were wedded to physics. And unfortunately for us, that and even Schumpeter, the person who talks about upheavals and the state of creative destruction and so forth, even Schumpeter said, Walras is the greatest of all economists. And he said, you know, he's the only economist who will stand comparison with the achievements of theoretical physics. So even Schumpeter was sort of obsessed with this idea that we should be like physics. And Walras actually said, well, one day the laws of economics will be just like the laws of astrophysics. He said, you know, complete, incontrovertible. And that, I think, was where we went wrong. It was a trap. Because what we did was we ran away from physics and we moved over to mathematics. And there we had adopted the sort of axiomatic approach that de Broglie pushed. And what is very sad is that took us right away from the discipline that was changing. Physics was changing, it was statistical physics and so forth were becoming important, and we moved away from that. And I think that what we need is a real paradigm shift, not just tweaking, improving, but think of biology. Now, biology, which was Marshall's favorite analogy, biology has gone through two paradigm shifts. One was you used to have biologists who had sort of ostriches and animals in their laboratories, and you'd go there and you see all these interesting organisms. Then molecular biology took over, and molecular biology completely wiped out the other guys. And somebody said here, this was actually the chairman of the biology department at Harvard. He said, biology must now be subsumed under molecular biology. All of the people working on any other form of biology were barking up the wrong tree. That tree was all dead wood. And that was a summary of how people felt. And suddenly, biology, looking at all these interesting animals, was sort of a sideline, and molecular biology was the thing to do. But biology moved on. And now what's happened? The current paradigm shift in biology is back to integrative or systems biology, which is being populated by individuals trained in physics, computer science, mathematics and engineering, who learn biology and work with biologists and test their ideas. And this is called what Phil Sharp called the process of collaborative science, or convergence. And that's taking place in biology. And Marshall would have been delighted with that. But unfortunately, we don't seem to have got through into that second step. We're still stuck with Lucas, who said the only assumptions we should make are on individuals. And as long as you're stuck there, we're not going to get very far. And I think the important thing to understand is that macro phenomena emerge from the interaction between the different components of the system. And you can't understand the functioning of an anthill by taking an individual ant and examining him in great detail. You need to understand how they interact, how they construct what's going on. And perhaps the best quote on this subject is from Phil Anderson, a Nobel Prize winner in physics. And he said, the ability to reduce everything to simple fundamental laws does not imply the ability to start from those laws and then reconstruct the universe. And that's exactly what we try to do. We start with the individual, and then we try to build from that, from our understanding of the individual, the whole system. And what Phil Anderson said, at each level, as you add more people, then what happens is that the fundamental laws, new fundamental laws come into play. That doesn't mean that the old ones don't have any value, but it means that there are new ones which you could not explain from examining the individuals. So instead, at each level of complexity, entirely new properties arise. And we have to take that into consideration whenever we're talking about macroeconomics, whenever we're talking about macroeconomic policy. It's no good looking at what an individual would do or how he would react. We have to think a bit deeper than that. Okay, so here's a number of people, of course. This, I'm not the sort of preacher who's telling you this for the first time. Many people have pointed this out. Charlie Koopman said, the reason that things go wrong at the macro level is not because people are different and so forth, it's because these people interact with each other. And if they start to imitate each other, then of course you get these waves of movement in the population, waves of pessimism, optimism, and the law of large numbers no longer works. And this is an old criticism. Poincaré actually criticized Bachelier in his thesis, and he said the problem with Bachelier's work, beautiful work, nice mathematics, but it doesn't take account of the fact that people are like sheep, and people tend to follow other people. And once you have that, all the laws that Bachelier developed won't work. The efficient markets hypothesis is dead. He didn't say it in those words, but that's exactly what he meant. And it took a long time for people to realize that. Okay, so what do? We study equilibrium states. We believed, in some sense, that the invisible hand would get us to one of those states. And that's just a conviction, a belief. We've never been able to prove that an economy out of equilibrium will go into equilibrium. But we study that. And so think of what's going on. What you should worry about is the dynamics of these things. You shouldn't worry about the individual states. You shouldn't study, let's look at the world if it was 3 degrees warmer. That would be interesting. And now let's see what happens if it's 4 degrees warmer. That's of no interest, because if you ever get to 3 degrees warmer, then the processes underlying that will take you elsewhere. So studying those as equilibrium states is a wrong, misleading idea. Let me give you quickly 2 analogies. This is the Western Antarctic ice sheet, which is subsiding into the sea very fast now. And we are in part responsible for that because, of course, we
are in part responsible for global warming. But the interesting thing is, if you ask people, how's that happening? They say, oh, global warming, because when things get warmer, the ice melts. But it's much more than that. What's actually going on is that because of global warming, the winds have changed. And winds are now pushing warmer water into the Antarctic region. And it's that that's undermining the Western Antarctic ice sheet. We always find simple explanations for more complex phenomena. And that, together with the ozone hole, which we in part managed to counter. But here's the important point. There is no stabilizing mechanism. So trying to do things in a system like that, which is evolving, trying just to solve it by saying, oh, but there will be, it will be back to normal. You still hear in Australia now, I got a note from the Australian National University at Canberra. They said, well, the university has to be closed. We don't actually have fires near us, but the air is so bad that we couldn't keep the university open. And they said, when things are back to normal, they said, then blah. But where's normal? And is it going to go back to normal? And that's the sort of thing we should be worrying about and thinking about. And that's true of the economy as well as the physical system. And that system, unfortunately, has organized into an unstable state. And people don't like the idea of that. There's another example, the megafires, which at one time, fires and forest were sort of compatible with each other. The fires were a natural way of regenerating the forest. Now that there's global warming, the problem is that it's drier, the wood is drier, and what happens is that we get these sort of mega fires, and what happens is they actually create a little microclimate which engenders electrical storms, which engender lightning strikes elsewhere. So this complex process has now got into a different phase, which is very difficult to control. And also there are the famous peat fires, which are going on all the time. 15% of the emissions of carbon in the world are produced by these peat fires, which are constantly burning. We don't know much about how they get generated and what we could do about them. But those are the sort of processes that are going on in the natural world, and they interact with us, and we're in part responsible for that. And in the economy, you could think of the same sort of story. That is, there are processes going on, the system self-organizes, and then you say, oh, wow, that was bad. How did that happen? That's exactly what happened to us in 2008. So, just to say to you, where are people working on this sort of thing? Am I just preaching in isolation? No, I think you'll find that all of those people there, academic institutions, you see the list there, they're all working on complex systems, on agent-based modeling and so forth, and a lot of distinguished institutions. And even governments, and the US gets upset at the OECD when you say this, even the US Treasury and also the UK Treasury have models, ABM models, which are associated with this idea of a complex system in which the interaction between the individuals and the institutions generates the aggregate behavior. And that's the sort of thing that we should be studying. Conclusion. We cannot continue to analyze equilibrium states in macroeconomics and not worry about how we got there and where we're going. Macroeconomic phenomena are the result of complex interactions and feedbacks between the components of our system and with the physical system in which they are embedded. And I see people like Doyne from the physics background who've been saying this for a long time, but I think we still haven't really got that message through. And we have to accept that that's the case, and I think that this conference is an indication, at least, of a willingness to do that, thanks to Angus. And if anybody's interested in complexity in economics, that's an evolutionary biologist, David Sloan Wilson, and myself. We edited a book called Complexity and Economics. And that's it. Thank you very much.